4 o'clock. Okay, so I can't speak. What the fuck? Okay, so okay, I think okay. So okay. Oh, is it okay? Is it okay? Yes. Maybe. Okay. Yeah. No. Okay. Cool. So pretty much. Okay. All right. So let's get started. So first of all, guys, it's like 4 a.m. or almost 5 where I live. But anyways, I'm just gonna do a recap on AWS Serverless. All right. So let's get started. So first of all, we're gonna do this as a Brainrot recap because I have Brainrot. Anyways, let's get started. Okay. So first of all, I'm just gonna ignore all this bullshit for now. This is the load balancing, obviously. We have the messaging and the asynchronous behaviors, and we have the SNS, which is simple notification system, queuing system, and then the queuing system for you can pick from the queue, and then you can process from the queue, you can delete from the queue. So all the notifications are not bothering you every single time. It's for certain event logs, just in case you want to sort of track what's going on between the components, just in case it fucks up. Okay, that's pretty much the best explanation I can give you. So apart from that, let's go on to the next one. So that's serverless. So serverless is obviously you don't have to worry about the servers and stuff. It's all like configured already, and all you need to worry about is just putting your code. If it fucks up, then you move on to Lambda. So Lambda is obviously event driven and it's serverless. So there's two types of this fucking microphone's getting on my face. But anyways, there's two types of serverless ways of doing this. So there's Fargate. Okay, so I'm just gonna call it FG. And we have Lambda. Okay, so Lambda is obviously event driven. So this executes in like event basis, and this executes in containerized applications. So for example, you use stuff like Docker. Okay, so think of this as a Docker container. So these containers you could orchestrate multiple containers. Okay, consider this to be another container. You can orchestrate all of these using Kubernetes, which is an orchestration service. Okay, so that's what ECS and EKS stands for. It's a containerization service. Kubernetes service. Okay, so Fargate is obviously containerization. Containerized applications, deploying them on a serverless basis. Okay, so infrastructure, it's a global infrastructure. There's multiple availability zones, and availability zones is like in a certain region. If there's like multiple locations, so if one spot fucks up, then you can move on to the next spot because it has backups in certain cases. Okay, not in every case, but in certain cases. So edge locations are like the closest location. So in most cases, you can have the infrastructure. Let's say you were living in, I don't know, like Canada, you can have the infrastructure running here and your client could be living in, like, I don't know, Narnia. So you can pretty much send the data, so like the data of the application near to the client, and then the infrastructure could be running in a server nearby to you. This is called edge location because it's nearby to the client, therefore everything's going to be retrieved much faster, right? So that's the whole idea. Anyways, let's go on to provision. So provision is, let me just double check on this one. Just give me a second. Okay, so Beanstalk and CloudFormation. So CloudFormation, as we call it, CloudFormation is a, how do I explain this? CloudFormation is a infrastructure as code. Okay, so it's like basically it's like for CI/CD pipelines, for example. So there's a single code deploy, which pretty much automates the process of like running tests and just doing the whole life cycle of getting your application from the test phases to the deployment phases to the getting things up and running to like basically the whole life cycle of CI/CD. Okay, so pretty much basically when it comes to CI/CD, so where was I? Okay, so CloudFormation is infrastructure as code. Okay, so that means like it supports two types, which is JSON and YAML, which is the two scripting languages that's supported by CloudFormation. But when it comes to this, you need to remember one thing. So for example, when it comes to CloudFormation, there's another side. Okay, so the other side is obviously Terraform. Terraform is supported by all the different cloud platforms, except it has its own how do I explain this, scripting language. Okay, so it's not JSON or YAML. And it's better to learn Terraform because it supports AWS, GCP, and Azure. Okay, so let's go on to Elastic Beanstalk. So I don't really remember what Elastic Beanstalk stands for. So let me just make a note out of this. Ignore this. I'm just what's the word for it? I fucking forgot. Manifesting. That's the word for it. Okay. Anyways, let's move on. Anyways, so Elastic Beanstalk and CloudFormation. Okay, so let's say Elastic Beanstalk I think it was Elastic Beanstalk. Yeah, Elastic Beanstalk and CloudFormation. Okay, so that's basically what we're looking at over here. Can I fucking... There we go. So Elastic Beanstalk and CloudFormation. Okay, so let's move on to Elastic Beanstalk. I don't remember. So, okay, Cloud Orchestration Service. So that's what this is, okay? So Cloud Orchestration Service. And I don't understand what's the difference between the others though. But anyways, Cloud Orchestration Service, infrastructure. So that's what we manage with this. We just double check on that. There we go. So Web Infrastructure Management Service, and it supports okay. So EC2 is like the servers, and S3 is pretty much for simple storage. So for things that don't require a lot of complex stuff. This is relational databases. This is non-relational, and this is for like simple stuff, right? Once again, closely related to S3. So pretty much what we're gonna do is we're gonna go into CloudFormation. So I've explained what CloudFormation is. Let me show you guys. Wait, hold on. What? And helps to what? Automate resource or automate resource provision. That's why I was so confused, because you can automate shit with the scripts, right? So networking. Let's go to networking. Okay, that's good. Okay, so there's VPCs, okay, virtual private clouds, and inside these VPCs you have subnets, okay. So there are certain ones are private subnets and certain ones are public subnets. The public subnet is basically what you see as soon as you like access a website, for example. But a private subnet contains things like databases within them. Let me actually I have Brainrot, so let me just double check with that. Public subnets are where publicly available resources will be put, and private subnet is where the privately where secure databases and secure data need to be kept in a VPC, correct? Cool. Okay, so in a VPC, exactly. So as you can see, so the user, so when a user makes a request, it sends it first to the VPC, right? Okay. I mean, it sends. Okay, yeah. I mean, I get that, but like, okay. So once it's gotten through the public subnet, the VPC is a network container that holds. Right. I get that. Public subnet is where the user might connect to. Public subnet. So it's pretty much like, okay. Sorry, I need to clarify this. Double check this. Okay. So let me just double check. Okay, let me just get this over here. I just fantasize about what I'm supposed to buy if I just, locked in properly. Anyways, let me just copy this real quick and we go back. Anyways, let's move on to, so this is the VPC obviously, and this is the internet gateway. So this is the VPC which is within the cloud, and you get it through the internet gateway. So you have Route 53, and it sends it back to CloudFront. CloudFront sends it to the Elastic Load Balancer, and then Elastic Load Balancer sends it to what was it called? Yeah, so Elastic Load Balancer pretty much sends the request to the VPC, and the VPC sends the request to EC2 instances which have Lambda containers, and then a Lambda container. So obviously Lambda makes the request to databases, and then it retrieves from databases, and then it pulls it back to you, basically. So like in response cycles, request response cycles. Okay, so let's go on to so this is a virtual private gateway. So I do need to lock in on this part because I did lose a bit of it's the VPC, virtual private cloud. Anyways, let's go on to subnet and access. So subnets, private subnets, exactly. So it's about next access control list. So pretty much, it's like there's the stateless and stateful filtering. So for example, stateless is like obviously it doesn't keep state, so you need to log in every single time. And stateful is for things that don't require as much complex security. So pretty much it remembers who you are the first time you log in, so that way it's easier, right? So as you can see, stateless packet filtering is for complex security reasons, and this is for less complicated security reasons, because it keeps the state of who you are, as you can see. And let's go on to, as you can see, this is a configuration image. So let's move on to the global networking, and this is DNS. So DNS is basically like, okay, so behind each of these websites, there's a IP address, okay? So once you see this IP address, you can pretty much get access to like the ports behind it, and the ports are obviously like services that are running behind this IP address, which is basically running this this URL. Okay, but okay, I shouldn't have said that part because that's on the cybersecurity anyways. Route 53 is the DNS service for AWS services, and then CloudFront is pretty much what it sends the request back to. CloudFront sends the request then to the load balancer, and then that sends it to the EC2 instances where Lambda and everything is going to be deployed. Okay, so as you can see, the DNS connects the IP address to the resource name, isn't it? What name? What name does it connect to? Resource. So pretty much it sends DNS connects the IP address to the what name? Let me double check. This is like a right. So domain name. It should be the domain name, right? What the fuck is this bullshit? Okay, it should be the domain name. Let me ask GPT. Domain name. Okay, there we go. Let's go on to storage and DBs. So we're relational and non-relational. So okay, block store stores everything as blocks. So why are data stored as blocks? Okay, that's a question that I have. EFS, Elastic File System. So again, I talked about this. Non-relational. Redshift is basically AWS's caching. So it's like Redis in a way. So everything is sort of temporarily stored on caching databases for to improve load times of applications. Just by saving the data that needs to be that way it doesn't need to rerun every single time. Let's go on to EBS, Elastic Block Store. So as you can see, everything's stored in snapshots. So like it doesn't overwrite existing data. Instead, it just overwrites. It just only adds like the new stuff that needs to be added. So it doesn't add. Everything is saved as snapshots, by the way. So I think I've already mentioned that. EBS is a service that provides storage volumes. So let me just do storage, as you can see, and yeah. So pretty much, it's easy, just like that. So S3 is simple storage. And as you can see, this is so S3 stores data in this format. It has an object level storage. Storage contains objects. So for example, data, we have the metadata and the key, which is a unique identifier. And so any file type can be uploaded onto S3 and EBS, and this is S3. So this is Elastic Block Store as blocks. S3 stores data as I don't know, fucking objects. Okay, objects. There we go. As objects. Let me just double check. Should be right. Yeah, there we go. Let's go to Elastic File System. I still don't understand the difference between these. EFS, Elastic File System, does not disrupt applications. So Elastic File System does not disrupt applications. You should see that right here. And RDS, relational databases. So Aurora is basically Amazon's quote-unquote better relational database. So it's offered directly by AWS, and as you can see, it's a relational database service. That's what this is. DynamoDB is a non-relational cloud database. As you can see, it's a non-relational NoSQL database, and DynamoDB versus RDS, which is non-relational versus relational. And for relational is better for complex applications, but it's slower. Complex applications that have a lot of records coming in. But for simple applications, it's unnecessary, to be honest. Okay, so big data analytics, once again, we use Redshift because it's much better in terms of caching. And so as you can see, I need to refer to this. It's a big data analytics, big data service. Okay, let's just search up service, big data analytics service. Okay, so let's move on from here to DMS. So database migration services. So for example, it used to combine multiple databases into a single one. That's what this is. So let me just copy this and oh fuck, I just fucked up. As you can see, combine multiple databases into a single one. And cloud security. So let's go to database services. So this is the document DB, which is in MongoDB style. So everything's sort of organized as documents. And so yeah, that's pretty much as far as Elastic Cache. So this is oh wait, Redshift. Wait, Redshift is different, my bad. So Redshift is actually a big data analytics service, and Redis is the caching service. Okay, so AWS Redshift is a big data analytics service, and Redis is the caching service. Cool. All right, so let's move on to the next one, DynamoDB Accelerator. So this is an in-memory cache service for DynamoDB. So this is a cache service for DynamoDB. So it accelerates the performance pretty much. So it's a cache service. Okay, let's make this clear. Let's say it's a, how do I do this? Let's say it's a cache. Oh fuck. It's a cache service. Okay, cache paper. Fuck. Never mind. Let me just do that. And I think part of my screenshot is gone. Okay, never mind. The cache service, as you can see, in memory cache service for DynamoDB. That's why it accelerates the performance. That's why it's called DynamoDB Accelerator. Okay, so let's move on. So Neptune is a graph database service. I'm pretty sure it's a graph database service. So as you can see, graph database service. So AWS Neptune is a graph database service. So let's say, for example, cloud security. Let's see what this is. No. User access. Let's see. IAM. Nope. I don't fucking like this. Pretty much you have the root user, and you have different users under that could be created under the root user with different permissions. So for example, you would create a group if you want to give shared permissions, and if you want to, share permissions to certain users, and yeah, so you can update policies on each individuals and give them roles for certain individual users, and 2FA. So this is for 2FA, and you get the point. So I think it's pretty clear. So this IAM policies are for cross-origin resource sharing, and for example, HTTP methods and stuff like that. So policies of database storage. Okay. So once again, shared permissions, as you can see. Report represents, IAM represents an entity. That's what it represents. Okay. So a person on an application. So once again, we have 2FA. Once again, like OTPs and emails and stuff. Organizations, once again, allows you to manage multiple different accounts. So groups are different. Groups are basically shared permissions, but organizations let you manage the different AWS accounts. It's like a container for AWS accounts, and you can manage multiple AWS accounts from an organization. Okay, even like bills and stuff. Okay, organizations accounts, exactly. So right here, let me just double check this. BP. All right, so DDoS is obviously a distributed denial of service. So it's obviously sending bombarding a certain server with a bunch of billion different requests. That way it just fucking crashes. So yeah, that's great, I guess. Artifacts, and we have reports. Okay. Sorry, agreements and reports. My bad. I fucked up. Agreements and reports. Okay. So I think we should elaborate on this a little more, so that way it's like it goes in our heads. Anyways, let's go to DDoS. So CloudWatch watches over, helps you watch over your resources, AWS resources. So CloudWatch, actually, we use this thing called Lambda login library. So remember when I said where the fuck is it? So you remember when I said serverless applications, we have Fargate and Lambda. So obviously right here, what happens is so Lambda login library. Okay, so I'm just gonna call it LLL. Lets you so any errors that are happening within the Lambda deploy, you can use the Lambda login library to push it onto CloudWatch logs. Okay, so I'm just gonna call it logs. So once you push it to CloudWatch logs, you can pretty much monitor everything from there. You can also set certain limits. You can monitor certain alerts, for resources and stuff like price limits and etc. So that's what that's for. And CloudTrail is pretty much everything. Everything is logged as a trail on using CloudTrail. Trusted Advisor is an AI-based automated system which sort of gives you advice on what needs to be done and what not. Like for example, pricing, using to overusing certain resources, like how you could optimize it for the better. Anyways, let's move on to pricing. So pricing is free tier, so that's 12 months for free. Not for free, but it's sort of like a trial. And we have on demand, so you pretty much pay as you go. And we have a contract basis, which is a few years, maybe 1 to 3 years, for a discount in exchange. Okay, so I'm just gonna call it this, and this is on demand, so you just pay as you go. Okay, so let's say, for example, you pay as you go, and yeah, so that's pretty much it. Free tier, pricing models. So billing dashboard. So you have everything sort of on together on the billing dashboard, and so yeah, so consolidated billing. That's pretty much having bunch of different accounts or billing in one bill, multiple bills on the one bill for multiple accounts, and Cost Explorer. So this is a marketplace, so you can sell all the stuff that you so vendors can sell AWS services on the marketplace. And cloud adoption framework. So we have re-hosting, re-platforming, repurchasing, I forgot the rest of it. Let me just double check with this. Give me a second, guys. Okay. So CAF cloud. No. With migrating applications to the cloud. Pretty sure that's what it is. Oh, transferring. Framework that so the migration of applications. That's with migrating applications. Yeah, exactly. So go to migration strategies. Okay, right here. Rehosting, replatforming, refactoring, repurchasing, retaining, retiring. Okay, so migration strategies. I need to sort of gamify this a little bit, else it's not gonna go in my head. Snow family. I don't think you need to know about this, to be honest. This is like fucking great for big devices, pretty much. Snow family devices can transfer up to pixabyte. No, pixabyte. Was it pixabyte? I don't know. Exabyte. Yeah, bytes of data. And burst behavior. That was Lambda, I'm pretty sure. Anyways, exabytes of data. Let's go on to serverless. So serverless is what I'm gonna move to next. So event submission, once again, it's asynchronous workflows. And if I show you guys here, so simple queuing service. So simple queuing service takes the messages from simple notification system, and then it pushes the message from SNS to SQS. SQS picks from the queue, and then the processor from queue, and then deletes from queue. Okay. So as you can see, asynchronous event submission with an SNS queue creates a synchronous connection between Lambda and API request. And the API request, right? Asynchronous event submission works. So as you can see, standard. So standard queues. Pretty much, you can't. You get infinite amounts of messages with one request. Except you don't really get everything grouped together properly. So it's very messy. But the simple what do you call it? The first in first out queue, only that's 300 messages at once, but it groups everything by ID. So that way it's easier to manage. As you can see, group message order is assured based on the ID. So simple queuing service. And workflow, so obviously these are step functions. So everything in a workflow, there's different procedures. So they are called steps. Okay. So we execute them as steps. So they're called step functions. Okay. So apart from that, so step functions work in steps. And client polling, so that's obviously like, for example, client polling is like in a long running transaction, you initiate it, right? Obviously. And once you initiate it, there's going to be like a message ID that you need to use. So you're going to be given this single message ID. And once you use the message ID with the long running transaction, you can understand what's going on with the transaction and see what's happening later on. So after you initialize it and you spend some time sort of how to explain this. So let's say, for example, a long run transaction, you initiate it, and once you get this thing called, okay, so this is AWS. AWS gives you a message ID, so I'm just gonna call it MID. And once I get this, you can pretty much refer to this every single time you want. You can use this here, and then you can get a status updates on this long running transaction. Okay, yeah, long running. Let's just call it LRT. Okay. So let's move on to step functions work in steps, obviously. So webhook SNS. So this trusted, and untrusted. So untrusted is obviously third parties, and trusted is basically approved systems. Maybe even in ACLs, access control lists. Okay. So webhook pattern has trustworthy and untrusted clients. API gateway, so it's obviously request response cycles. AppSync is a GraphQL service for APIs, so it's much better. It's a GraphQL service, as you can see, that offers real-time data sync, and it's much easier when it comes to keeping things up. So let me just double grab this. It's a GraphQL service that offers real-time data synchronization. So offline development capabilities, automatically subscribe to status updates, subscription returns data when it happens. It's also called a real-time update. It is best suitable for data-driven user interfaces. Okay, so let me just paste this here, and let's move on. A status update. Okay, so let me just use status. We grab this, and as you can see, boom. Okay, so let's move on to claim check. Interesting. Oh yeah, this was a pre-signed URL, so you can access some object with it. So that's what a pre-signed URL is. Okay, so it's assigned to a certain object, so that's why you use that URL. Okay, using that. It's a pre-signed is a URL, and URL that is that has access to some object. That's a pre-signed URL. Okay, so let me just it is. So data processing, we have a stream is a high rate of, so think of it like live streaming. Obviously it's on stream, so it's fast, right? So pretty much, let me just double check. So two types of AWS services. Wait, fuck, what was that? Two types of AWS Kinesis services. Producers and consumers. Interesting. Okay. Something I missed. I double check on this. Kinesis is obviously for Kinesis streams are for large scale applications. For Firehose is for simple applications. A stream is basically a large flow of data, and a message is an individual message, obviously. And so streams, streams obviously keep track of the messages, and messages once it's read, unless there is a dead letter queue and a retry. What was it called? So unless there is a dead letter queue, where was it? Not this, my bad. So for failures, you have to set up retries and dead letter queues. So it retries until it succeeds or runs out of time. So obviously this is a stream of messages, and this is individual messages. So that's what it is. Streams, flow message, high rate of messages. I mean, stream of messages. Streams. What the fuck? There's a different definition here. What the fuck? Am I tripping? Okay, let me just copy this real quick. Let me just grab that. Cool. Let's go on to failure management. And so use CloudWatch logs. That's obvious. And CloudWatch logs can help you overcome failures in your code. Error sync and async. So synchronous is obviously it doesn't retry, and asynchronous waits for something to be done. So exactly right here, and asynchronous waits for things to be done and then moves on to the next thing. So as you can see, so the retry value. So this is important. So right now I'm having a brainrot session, so I'm not going to. So function calls and so there's function calls and no, function errors and call errors, right? So function errors are when calls don't work. I mean, functions don't work, and call errors are when calling a certain endpoint doesn't work. So function errors and call errors. So we just copy this real quick. Fuck, that is fucked up. Okay, there we go. And let's move on to. Let me just go from the back to the top. So this is serverless application development module deployment. So it's obviously like, as it says, serverless application development module. So You can interact with it using the CLI, the guided command for interactive environments like this, or you can in fact use there's different ways of interacting with it. So this is the easiest command, as you can see. So you can deploy using this as well. So this is the SAM package. So they're all under the serverless application development module. And auto deployment. So this is the CI/CD phase, as you can see. Flow pipeline is obviously the automation of the CI/CD, a software release procedures and quality checks. That's what a CI/CD pipeline assists you with. So let me just get that real quick. Serverless deployment strategies. All at once. So all at once deploys everything at once. So that doesn't check for any errors or any of that. Canary, Canary's second, Canary's a little slower, but also it's a little cautious about errors. Linear is extremely slow, but then it's more cautious about the problems and make sure certain application doesn't fail, right? So it's good for large scale applications. Now we have X-ray, which gives an X-ray of what's happening in the application. Serverless deployments. So that's obviously automated activities. Deployment is the transfer. Transferring the current application to a server. That's what it is. Exactly, right here. So CloudTrail and config. So as you can see, so CloudTrail is logs everything as trails, and that's what we see here. And a configuration that enables the logs of cloud. Is a configuration that enables logs of the what the fuck? Okay, there seems to be a big problem here. I fucking don't remember this, bro. That's crazy. I swear I fucking studied this. Let me try again. Delivery of CloudTrail events. Okay. Let me just copy this real quick. The CloudTrail is the delivery of CloudTrail events. Let me just try that again. A trail is the delivery of CloudTrail events. Cool. Let's move on. So deployments. So that's obviously serverless deployments. Securing. Let's see what this is. What's under this? Okay, limiting access to APIs. So Cognito is Amazon's built-in authentication system. So authorizers lets you customize the what do you call those? Customize the authorization, right? As you can see. So let me just. So authorizers are better for custom use cases, and Cognito is better for usual sign-in, sign-up type of basis. So IAM is used for access identity-based access management, and so scaling kinesis is for streaming, right here. A function error. So there's different ways of handling this. Okay. First one is a function error, maximum record age, and failure or retry attempts, and a failure destinations. Okay. So this is the 4 ways of handling kinesis streams. So let me just copy this. Let me just paste this here. Scaling step functions, once again workflow-based step functions. And activity worker communicates between services to receive tasks and perform them. So that's what a exactly, so scaling step functions. Double check. Right here. An activity worker communicates between services to receive tasks and perform them. That's what it is. Okay. An activity worker communicates between services and receive tasks and perform them. Cool. Let's move on. Scaling databases. So dead letter queues are obviously where the messages that are not delivered goes. And so again, I've mentioned what this is. This is a caching-based database service, which accelerates the performance in turn. DynamoDB accelerator. That's what it is. That's what a DAX is. Scaling. Can directly terminate. You cannot directly terminate the connection when the lambda function is destroyed. I'm pretty sure that's what it is. Lambda environment is destroyed. Okay. You cannot directly terminate the connection when the lambda environment is destroyed. Let's say that. However, so lambda environment, that's obviously this, and a function execution speed. Execution speed is going to improve a lot if you pretty much do that, right? So let's move on. DynamoDB accelerator, and power tuning is giving certain functions more memory. That way, you know, it performs better because certain functions also need more memory, right? Allocate more memory to functions. Exactly, right here. Let's go on to execution speed, okay, by reusing execution environments. Because it caches stuff, right? So it's obviously faster next time. Concurrency maximum number is 8,000 when it comes to Lambda. So scaling API gateways, Lambda maximum concurrency is 1,000, and concurrency authorizes help you make custom authentication calls. Create a custom authentication process. Is it process calls? Let me double check. Yeah, there we go. Concurrency is obviously running multiple different instances in the tasks at the same time, like Lambda tasks. So you can run up to 1,000 different tasks at the same time. Is the execution of concurrent concurrent lambda calls is the let me double check with this, give me a second. I fucked up. Number of concurrent calls. Okay, so let me just copy this real quick. Concurrency is the number of concurrent lambda calls. That's what it is. Number of concurrent lambda calls. So let me just grab this real quick. And yeah, so the number of lambda calls, concurrent lambda calls, which is a max of 1,000. So let me just put that real quick. So you get a max of 1,000 calls. Okay, so yeah. So let me just grab that real quick. Let's move on. Serverless at scale. Oh my god. Managed services provide I don't know, availability, security, and accessibility, I think. Yeah, scaling, security, and accessibility. Okay. Scaling, security, and accessibility. I can't spell that. So let me just paste that here. Web and mobile apps. Let's see. Cognito. Let me just copy this real quick. Fuck, I fucked up. There we go. Cognito is used for signing up and login. So you can use S3 bucket to store website assets. CloudFront is used to distribute. You can use CloudFront distribution to offer those user assets to users globally. So that's what it is. Let me just copy this real quick. All right, let's move on. So this is the execution lambda function at a predefined time. So you you schedule a lambda function at a predefined time to execute. That's what a schedule lambda function is. SNS filtering. Publisher delivers a subscription, a message to a update to a subscriber, I think. Fucked up here. Publisher delivers a messages to his subject. Exactly. Messages to the subject. There we go. Message to the subject. That's what it does. Copy this real quick. Paste that here. So Fargate is obviously, we know what Fargate does. And migrating to serverless. Server error sync versus asynchronous. Once again, you can see that here. Failed events on failure destination. So that's where like the dead letter queue, all the messages from the dead letter queue ends up in the on failure destination. So that's where everything is. So you need to execute retry calls in order to deal with certain messages and the failures. And finally, it ends up in the on failure destination. Okay. So on failure destination is where messages, or sorry, data is stored when a function fails. Execution, I mean function technically, or execution. Let me just double check. Function fails. There we go. Let me just close these real quick. PC fans are going crazy. All right, so let's move on to. I think we did these, didn't we? Yeah, we did these. Processing the same same task multiple times. Pretty sure that's what it is. Same records multiple times. Same records. Let me just double check one last time. Okay, there we go. So processing the same record multiple times. That's idempotency. Whatever the fuck this is. Let me just get a snapshot of this bullshit. Kinesis data streams. Firehose. Firehose is used for simple applications. And yeah, so we use the CLI, the management console, and the API to access AWS. That's three ways of accessing AWS. CLI is obviously for things like serverless application development module, where you need to use the packaging, the deploy and the deploy guided command to be on the interactive basis. So deploy guided is what you use to have the interactive mode. So that's pretty much it. Man, I'm tired. Very fucking tired. But we covered it. I think we covered it. I gotta go through it again tomorrow, hopefully. And yeah, that's pretty much it for now. Gotta learn algorithms again. But yeah, that's pretty much it, guys. Hope this video was helpful, or live stream was helpful for a wrap up of the different things. Okay. So I've started using AWS. Let me show you guys S3. If anyone even sees this video, I'm not too sure, but I've started using S3, as you can see, bucket policies. So nothing complicated yet. So I've created a lambda function. Let me just show you. As you can see, I created this for a custom use case. So I could create an API gateway, as you can see, API gateway, right? So this is what we use to access the resource, obviously. So I can use this to access the resource. So this is my server. I've also deployed this over here because I'm still new to this bullshit. I'll just show you guys real quick. As you can see, if I go here, it's the same thing. It's just this deploy is under this, and this deploy is under this. What it is. So yeah, that's pretty much it. And I haven't really done much with this. It's just basic stuff. I've just connected these two, a lambda function and an API gateway, which is nowhere near the completed thing, right? So you need to set up multiple different things. But yeah, that's pretty much it, guys. Hopefully we get some hands-on experience with the certification. That's what I'm planning on doing next. But anyways, that's pretty much it for this video, guys. Hope you guys enjoyed, and I'll see you guys later. Oh yeah, one more thing. The key management service, right? So key management service is where you keep all the API keys and anything that needs to be encrypted. And yeah, I think we covered most of the stuff that needs to be covered over here. Cognito for user. It's basically sign in and sign up services, and API gateways for request response cycles, VPC for private and public subnets, CloudFront for the distribution of resources, and what else? Route 53 for DNS, and all these different stuff. Database microservices, transfer family, Snow family, AppSync for GraphQL based services, CloudTrail, logging everything as trails. What else? Identity access management, payments, payment plans, Cognito. What else? Queuing system, notification system. I mean, SNS, SQS. What else? Redshift, which is for big data analytics, and Redis, which is for caching, like basically like Redis, but it's AWS Redis. So this is under AI. Aurora, which is under AWS non-relational databases, so SQL based, and I mean relational databases, my bad. Code pipeline, which is the CI/CD automated. So you commit, you obviously build, you deploy. The pipeline is obviously what automates the full thing of the CI/CD. You can use CloudFormation with it, so it supports CloudFormation, and you can use cloud. What was it? Cloud pipeline supports CloudFormation. Yes. Yeah. So you can simplify the script using CloudFormation, just like this. Okay. So that's pretty much it. And what else? X-ray for the whole application. EFS, which is for Elastic File System, and EBS. Elastic File System does not disrupt the application, so that's why it's good. EBS also does not disrupt the application, so everything is in block store, Elastic Block Store, Elastic Container Service, Kubernetes, Docker, Kubernetes, S3 for EFS, Elastic File System, S3 Crasher. Yeah, Snapshot is a graph-based database service. DynamoDB relational, Aurora non-relational. What else? That's pretty much it, guys. Elastic Beanstalk. This is Container Application Infrastructure Management Service. EC2 Elastic Compute. So you use S3 with EC2. EC2 is with server configuration needed, unlike Lambda, which is serverless and event driven. Yes. Yep. Okay. Server-based compute service. Exactly. There we go. It's event driven as well. And Fargate is the containerized version. FGC. Let me just call it FGD because it's Docker for containers. Okay, so that's what it is. Anyways, that's pretty much it. Wrap things up for now. This basic summary of what's happening. And yeah, that's pretty much it, guys. See you guys later. Peace out. Oh yeah, one more thing. What was it called? What was that thing called? I fucking forgot. Oh, load balancing. So that's for balancing out the number of requests, especially for like DDoS attacks. We use the load balancer to balance out the traffic that's coming into the application, so that way it doesn't crash. Specifically to prevent DDoS attacks. Okay, I'll see you guys later. Bye bye. I can't fucking end stream because of